stress versus strain graph. Stress strain graph. In the diagram, vertical axis is stress. Stress is plotted along the vertical axis and strain is plotted along horizontal axis. We have to plot the variation of stress in terms of strain. First of all, stress will increase along OA linearly with the variation of strain. Beyond the point A, stress changes following a curve AB. Up to the point B, stress increases following a curve, and stress will change in this way following this graph. P is a point, and we can denote other points C, D, and E on the graph. If deforming force is removed, in that case the body will regain its initial configuration along the path BO1. We can denote the path or imaginary path BO1 along which the body will regain its initial configuration, and there will be permanent deformation OO1 if deforming force is removed from the point B. If and also in the region O to A, Hooke's law is obeyed. We can draw a normal from the point P. We can draw a normal from the point P, and also we can draw a normal from the point E on the strain axis. And also we can draw a normal from the point B on the strain axis. And the point P is the yield point beyond which strain is independent of stress. That means if stress is that means strain increases though stress is kept constant, or strain increases or strain occurs though no deforming force acts on the body. P is the yield point, and we can denote plastic region from the point P to C. It is plastic region. Now we can draw a normal from the point C. This is the plastic region from the point P to E actually, but it should be from the point P to C. This is the elastic region from the point O to A is elastic region in which Hooke's law is obeyed and stress is directly proportional to strain. We can denote a normal from the point A. We can denote a normal from the point A. And elastic region is extended from the point O to A. We can denote the elastic region from the point O to A. This is the elastic region. Now we can draw a normal from the point D on the stress axis or vertical axis. This is the imaginary line, and this imaginary line is drawn from the point D on the stress axis, and which gives the value of breaking stress. Which gives the value of breaking stress. The stress corresponding to the point D on the stress strain graph is called breaking stress. This is the breaking stress which is denoted on stress axis. Breaking stress is the stress at which breaking stress is the stress at which the material can endure before failure. The stress hyphen strain graph. The stress hyphen strain graph has the following regions. Has the following regions. Has the following regions and the points. The stress hyphen strain graph has the following regions and points. Elastic region. Elastic region. So we have to denote the elastic region which is confined from the point O to A. Elastic region is confined in the portion OA. The portion OA of the graph, the portion OA of the graph is a straight line. The portion OA of the graph is a straight line showing that stress is directly proportional to showing that the stress is directly proportional to strain, and the portion OA of the graph is a straight line showing that the stress is directly proportional to strain, and Hooke's law is obeyed in this region. Hooke's law is obeyed. Hooke's law is obeyed. In this case, the portion of OA of the graph, which is a straight line, showing the stress is directly proportional to strain, and Hooke's law is obeyed. Comma is called elastic region. That means the portion OA on the stress strain graph is known as elastic region. Elastic region. In the graph, the deforming force corresponding to the point A on the graph is called elastic limit. On the graph, the deforming force in corresponding to the point A on the graph is the elastic limit. So we can write that the deforming force corresponding to the point A on stress hyphen strain graph is the elastic limit, and the point A is called elastic limit point. The point A is called elastic limit point. So the portion OA is called deforming force at the point A is called elastic limit, and the point A is called elastic limit point. If the deforming force is removed, that is, wire is unloaded. That means if a wire is deformed and the wire is unloaded at the point A, the body, that means the deformed body, regains its original configuration. Its original configuration or length com- completely. It regains its original configuration or length completely, along the straight line AO, along the straight line or along the path AO. At the point A, if deforming force is removed means F equals 0, the body will regain its initial configuration along AO and there will be no deformation. Number 2. Now we can denote permanent strain region. We can denote permanent strain region. The curve AB beyond the point, beyond the elastic limit, the curve AB beyond the elastic limit point A is called as permanent strain region. It's called as permanent strain region. So the region or the portion AB is called permanent strain region. In this region, if the deforming force is removed, if the deforming force is removed, if the deforming force is removed, that is, the stress is reduced to zero. The stress is reduced to zero. The stress is reduced to zero. The strain will not follow. The strain will not follow the path BA, but the strain will not follow the path BAO, but it traces the dotted, but it will trace or it traces the dotted line BO1, BO1, but it will retrace or it will trace the dotted line BO1 and the portion OO1, the portion OO1 is actually permanent strain, and a permanent strain OO1 is produced. A permanent strain OO1 is produced if deforming force is removed at the point B. So O1 is the permanent strain produced in the wire if deforming force is removed at the point B. The point B, so deforming force at the point B is removed if the deforming force is removed at the point B. The deformed body or wire will regain its configuration, will try to regain its configuration, initial configuration along the path BO1 and OO1, OO1. In the graph, OO1 is the permanent strain produced in the body if deforming force is removed. Hence, OO1 is the permanent strain in the graph. Now, number three region. Number 3 is yield point and the plastic region. Yield point and the plastic region. Yield point and the plastic region. Beyond the point P, beyond the point P on stress-strain graph, stress-strain graph, beyond the point P, the stress produced in the wire or in the body is almost independent of stress. The body or wire is almost independent of stress. And it continues up to the point C. The point P at which the point P on stress hyphen strain graph, the point P on stress hyphen strain graph, the material of the body starts deform plastically. The point P on the stress hyphen strain graph at which the material of a body starts deform plastically, is called yield point. The point P is the yield point, and the portion PC of the graph in which the permanent permanent plastic deformation occurs is called plastic region. The portion PC of the graph in which the permanent plastic deformation occurs is called plastic region. The behavior of the material to this portion of graph from P to C is perfectly plastic. The portion PC is called perfectly plastic region, and this region strain is independent of stress. In plastic region, strain is independent of stress. The point P is called yield point. Number 4 region is ultimate stress point or breaking stress point. We have to denote ultimate stress point or breaking stress point. This is the graph. The stress corresponding to the point D on the graph at which the material or the body can endure before failure. That means the body can bear the load before breaking is called the breaking stress. The stress corresponding to the point D on the graph at which the material of the body can endure before failure is called breaking stress. Breaking stress. The stress corresponding to the point D on the graph at which the material of the body can endure before failure is called the breaking stress. The point E after the point D, the point E on the stress hyphen strain curve or graph at which the material or the body or the deformed wear, the point E on the stress strain graph at which the material or the body at which the failure of the material or the failure of the material or the body takes place. That means the body breaks, is called breaking stress point, is called breaking point, or the fracture point. The point E, that is the last point on the graph, is called breaking point or the fracture point. The point E at which the failure of the material takes place is called the breaking point or the fracture point. The, the stress corresponding to the point D is called breaking stress, and the material can endure before failure. That means the material can bear this stress before it breaks, and the point E is called breaking point or fracture point. The last point on the graph is called breaking point or fracture point. And once again, the point from O to A, Hooke's law is obeyed. Hooke's law is obeyed. Hooke's law is obeyed. And in this region, stress is directly proportional to strain. Stress is directly proportional to strain. And this region OA is called elastic region. And in this region, this portion of the graph is perfectly straight line. And from O to A, the region is called elastic region. And the deforming force at the point A is called elastic limit. And from A to B, if deforming force is removed from A to B on the graph, from A to B we have a curve, and if deforming force is removed, the body will regain its initial configuration along that imaginary line, and OO1 is a permanent strain or deformation produced in the body if deforming force is removed at the point B. The point P is called yield point, beyond which the body starts to behave as perfectly plastic body when strain will be independent of stress. Beyond this point deformation occurs plastically, and that means from P to C in plastic region deformation occurs plastically and strain is independent of strain. Strain is independent of stress. At the point D, material can endure before failure, and the stress corresponding to the point D is called breaking stress. If we draw a normal from D on stress graph, we get the breaking stress at which the body can endure before failure. The point E is called fracture point or breaking point, and at the point E, material breaks or failure takes place. Body breaks or failure takes place at the point E, and the point E is called breaking point or fracture point.